folks, in the tradition of minute physics, today we're going to show you how to derive the range equation in about a few minutes. Back in the days of warfare, World War I, World War II, we were trying to figure out how to shoot projectiles and hit the enemy soldiers without shooting them and hitting our own soldiers. Now, we knew there was an equation for that. It's called the range equation. Looks something like this. The variables in the range equation: x is equal to range, v0 is equal to the launch velocity, theta is the angle, and g is the good old gravitational constant of 9.8 meters per second squared. You set your variables up on the y-axis and the x-axis. You'll have an initial and final velocity, an a, your y, which is your height, and your time. Initial flying velocity x, an ax, and an x. The known variables in this equation are this. We're going to go from this point down. If we do that, that means our v initial y is 0 and our v final y is the opposite side of this triangle on the way down. And we're going to show you that on the next page. But basically, this is our velocity final y, and this is our velocity final x. So our velocity final y is going to be v0 sine theta. Our a in the y direction is g. Y we don't know, t we don't know. These two are equal to each other. That's because the x velocity of the projectile, how is it going horizontally, is 0. Once it's fired, it can't speed up or slow down. So these are both equal to v0 cosine theta. If you drop those variables in this, here's your vector triangles, and you'll be able to tell that we're just going to apply the big three equations. So these big three equations, when a is 0 over here, that'll cancel out those variables, and those variables. And our middle equation is most useful. In this equation, over here, there's too many unknowns in these two. So we're actually going to use the first equation to solve, and you'll see that the v1 cancels out as 0. Alright, so our v final is v0 sine theta, a is equal to g. With our equation, that gives us v final over a equals t. Our v final, if you remember, is v0 sine theta, and our a is g. In this equation, we have v initial equals v0 cosine theta. We're going to apply this equation. If you remember, this part cancels out, and there we get x equals v0 cosine theta t. Notice that t is there and t is there. If we substitute the t from this side into that side, we can combine them into one equation, x and y. But before we do that, we have to take our time and multiply it by 2. Remember, we used that trick where we said our v initial was 0 at this point. So that means we brought the projectile from there down. If we multiply it by 2, we bring it up and down. When you bring them together, you get this equation right here. It doesn't quite look like the range equation. Now it's starting to look a little better when we neaten it up. And when you remember your trig identities, you'll remember that 2 cosine theta sine theta is equal to sine 2 theta. And then you get the range equation. Once you know this, you can stop worrying about blowing up your own troops and start worrying about firing angry birds at piggies. The end.